Good afternoon, Tad Hack. My name is Mike Carnes, and I'm here to talk to you today about my hack that I'm calling IoT Smart Room Flags. Good afternoon. My name is Mike Carnes, and I'm a senior contact center consultant with AT&T Consulting. I've got around 20 years experience in technology, and I'm here at Tad Hack for something new to try out. So this is my first time doing this, and I decided to pick a healthcare situation. One day while I was in line at the doctor's office, I noticed the colorful flags that are always outside of the exam rooms, and I asked the triage admin what they were for, and she told me that they were for communicating the status of the room to the nurses, doctors, and other staff, so they know when it's appropriate to enter the room and for what reason. I took that and I decided to expand upon that technology and add a sensor to these devices to capture the status in an automated way. As I continued to explore what I could do with that information, I thought about it, and patients are sitting in a waiting room waiting to get moved into an exam room. Well, all those flags that are being statused out there it's a manual job. What would happen if we could expose what is actually happening to those rooms to an IT automation through IoT technology? So that's what I decided to do for my hack. I decided to take that technology, that primitive technology, and improve upon it and give it the ability to do reporting and real-time status of what that room is doing right now. So in order to do that, there's some technology that I thought would be required. The first thing that we would need is a database that would maintain the state of those rooms. So what I built was a DB database in Amazon Web Services. I also built a patient state database in AWS DynamoDB. Uh, but I wanted it, once you've got that data, you need to be able to communicate that data to people. So in an automated way. So what I decided to use was Lex chatbots to do that automation. And then use Lambda functions to call SMS messages or fax APIs for sending data to and from people as needed. And I need a rules engine that would allow me to make business decisions based upon the state of these rooms. If there's a room that needs to be cleaned, then the flag may be set to cleaning flag, and then the janitorial team comes in and cleans it. That type of thing. That automation, those business rules, I decided to do in Node-RED. And obviously, there needs to be a way to take the state of that flag, whether it be opened or closed, and pass that on to the automation engine. And to do that, I was going to use an ESP8266 IoT board or a similar technology. So the two things that I really wanted to shoot for my goal on this particular hack was to improve the patient experience and also at the same time improve the healthcare provider experience. So by improving the communication between the patient and the doctor via automation, we can do a lot of things like improving customer experience, uh, you know, reducing wait times, making your wait times more productive by giving you things to do. On the healthcare provider side, it could reduce costs by staffing to the peaks better. Triage could be automated via chatbot questionnaires. Faxes and other documents could be sent directly to the doctors when needed. The screen pop could be presented to a doctor when they need to get details right before they visit with the customer. This slide was just to depict that the flags would communicate directly back via wireless technology. So my goal with this particular slide was to show the patient experience how it could be improved if we used a chatbot to do the scheduling of appointments for customers and then send them updates based upon new information as the doctor's office gets it. In the example pictured here, the customer received an SMS alert saying that their results from a test was in. From the healthcare provider standpoint, we could improve their workload by giving them smart updates on their phone before they arrive in a room. A lot of times doctors need to quickly review a lot of information about you right before coming into the room, and having that at their fingertips as they approach would help. And finally, here's the flow that I saw of that IoT data as it came through. A doctor or nurse would flip the flag, the sensors and a ESP8266 microcontroller would send an update to a gateway. The application rules engine, in this case Node-RED, would flag the state of what the room and what it represents. Then a real-time patient state and the exam state are updated in real time to a dashboard. The rules engine can trigger workloads or workflows or chatbots depending on the need. In summary, I wasn't able to complete all of the hack in the 2 days allocated, but I was able to build several design documents and begin prototype each of the technologies that I would use to implement this as a real product. With a little bit more time, I will be able to actually implement this as a cloud-based design with just a few IoT microcontrollers and some cloud services. Thank you to everyone in the TAD Hack community. I appreciate your time and good luck to everybody.